Welcome to lesson 19. In this lesson, I want to review what is often referred to as long multiplication. This is the common technique for multiplying numbers, which are too large to simply rely on using the standard multiplication tables that people memorize. Well, actually, we do use the standard multiplication tables, but we begin by restructuring the task so they are more easily applied. So the purpose of this lesson is to make sure you understand how the restructuring process applies. We'll begin by looking at how we handle 406 multiplied by 54. Instead of multiplying by 54, we use multiplication by 4 and 5, which most students find quite easy. So again, we are changing the task to make it easier, and therefore we can do it quite accurately and quickly.
Our first multiplication step uses only the 4. Each little calculation uses the 4 times table. 4 times 6 is 24. Note that the calculation using the blue 5 begins under it. 5 times 6 is 30. Remember to carry the 3. 5 times 0 is 0. Adding the carried value, 3, gives 3. Multiplication is finished. Now we move to an addition calculation to combine our two subtotals. Note the use of the gold 0. Continue to add normally. The calculation is finished. Your answer is correct. Well done.
Were you comfortable with that? I hope the color coding of the solution helped you follow the algorithm being applied. Multiplying 406 by 54 becomes a matter of multiplying by 4 and then by 5. But notice, as was pointed out in the clip, the multiplication by 5 is moved one column across. That is because the 5 is really 50. So that's followed by addition of our two products, multiplying by 4 and multiplying by 50. So that gives a total of 21,924. Notice how the original task has been broken up into simpler components, so that any time we're only focusing on a component, you should recognize this as our standard approach to anything mathematical. Always try to break the task down into something simpler. Here is another example so you can see how this applies.
Our first multiplication step uses only the 5. Each little calculation uses the 5 times table. 5 times 4 is 20. Note that the calculation using the blue 9 begins under it. 9 times 4 is 36. Remember to carry the 3. 9 times 7 is 63. Adding the carried value, 3, gives 66. Multiplication is finished. Now we move to an addition calculation to combine our two subtotals. Note the use of the gold 0. Continue to add normally. The calculation is finished. Your answer is correct. Well done.
Now, to finish off, I want to extend this idea of multiplication. We'll use a very simple example, 2 times 54, which is obviously 108. Previously, when multiplying by 54, we made things simpler. We multiplied by 50, and then we multiplied by 4. In other words, we multiplied by components of the 54. So 2 times 54 is the same as 2 times 50 plus 2 times 4. This implies that whenever you have to multiply something complicated, you can make the task simpler by multiplying each of the individual components and then combining those results later. So the first component, 50, the second component, 4. We use this principle a lot in algebra, where the exact value of some components might be unknown at the time. So 2 times something made up of a known and an uncertain component is the same as 2 times the known and 2 times the uncertain. So we can process this and leave this to be completed later. So in algebra, fully process what you know now and leave the rest in a convenient form to be completed later. In the next lesson, I'll look at the process called long division. Most people find that quite difficult, not just students. So I'll see you then.